Yeah, question. Find the area of the parabola y square is equal to 4ax. Okay, bounded by its latus rectum. So this is the question. First to parabola. Okay, parabola equation is given. See, this is general form, general equation. Okay, when we have value in place of a, that is a particular equation. This is general form. We have to remember there are different formulae for different parabolas. So if you come across the equation like y square is equal to 4ax, 4a is constant. Okay, now you should remember, if the equation of a parabola is y square is equal to 4ax, then parabola will be like this. This is parabola. Okay, this is parabola. So O, this is O, not 0. O means origin. Okay, origin means what? Here 0 will be there. So this is 0. This this point I will take as O. O means origin. So coordinates of origin are what? 0, 0. I will write here O 0, 0. O means origin. These are 0, 0. Okay. So this is the parabola. This is the vertex. Okay. So the vertex should be this is the vertex. The vertex should be at the origin. Origin means this O. Okay. And this x-axis, this is x-axis, this is y-axis. This x-axis should be the axis of symmetry. Axis of symmetry means what? See, I will show it. Just simply assume, see, this parabola is like this, okay, like this. So this center line is there, no? This center line, it's like x-axis. This one, x-axis. Okay? Like this I will take, okay? So this center line, this is like x-axis, this one. This is this side. And this side is this, like that. Just assume, just to make you understand, I have just taken the book. This is parabola one curve, this is another curve. This side, this, and this x-axis is this. Okay, see, when you fold about this x-axis, see, when you fold, this and this will superimpose. Okay, like this. When you fold like this, here at the center, it is the x-axis. When you fold about this axis, this and this will fold like this. Exactly one will fall on another. Like one will superimpose on each other like this. Okay? Because of that reason, this x-axis is the axis of symmetry. Axis of symmetry. Okay, so when the equation is given like this, you should draw the diagram like this. So parabola should be like this, vertex should be at the origin, and this axis of symmetry will be x-axis. Okay, next another point, this line is there now, this L and L dash. Okay, this line is called latus rectum. Okay, so this one, latus rectum. Remember, see, from this point to this point, okay, if the length is A, this one, this length is A, then this point lies on this x-axis. So this point will be a comma 0. Okay, I will take this a comma 0. This a comma 0 is in the form of x comma y. So x is equal to a, y is equal to 0. Okay, that's the meaning. See, this point is lies on the x-axis, so y value will be 0. That's why this y is 0, and this x will be this a. From here to your length is there, no? This a. So coordinates of this point, this a, comma 0. Why 0? Because this point lies on x-axis. So when it lies on x-axis, y value becomes 0. Okay, this remember. Okay, and when you take a line, this is a straight line, vertical line. Okay, this vertical line, this passing through this point, this I have taken S. So this is focus. I'll write here focus. Okay, if the coordinates of this parabola a comma 0, coordinates are a comma 0, then this is called focus. Okay, a vertical line that is passing through this focus, and it has end points. See, this is the end point, this is one end point, this is another end point. So these end points, this and this, lies on this parabola. Correct? Yeah. So the end points, so this point lies on this parabola, this point also lies on this parabola. Okay, so now because of this is called latus rectum. Okay, so latus rectum is a vertical line, okay, that is passing through the focus, and it has end points, this and this, on the parabola. This is parabola. Okay, that is a latus rectum. Okay, according to the question, diagram is this. Now what is the question? Find the area of this parabola. Parabola we have drawn, bounded by its latus rectum. Area bounded by the latus rectum. So latus rectum is what? This one, L and L dash, this line. Okay, area bounded by this latus rectum means this one completely, this part and this part, this part and this part. So this complete area is there now. Okay, between this parabola and this line, whatever the area is there, this shaded part and this shaded part, this is the area bounded by this latus rectum. Okay, so to find area of this complete area, bound this part and this part, first we will find area of only this part, then see, I already said x-axis is the axis of symmetry. That means if you fold like this, so this curve and this curve will fall on each other like this exactly. Okay, so because of this axis of symmetry, this area will be equal to this area. Okay, when you find area of this part, and if you multiply this by 2, we get area of this and this. You got it? So first we will find the area of only this part, shaded part, then we will multiply that by 2, we will get area of this and this, that is area bounded by the latus rectum. Okay, so now our first aim is what? First goal, we will find area of this part only first. Okay, yeah, just one second, I will just erase this once. So I said this and this is the total area bounded by this latus rectum. So how can we take that O, L, then come here, this is L dash, then A will go back this, so O. So required area is, first I will take, let A be the required area. So A is equal to area of region, this one. I said this and this is the area. So we can take, so OL again this L dash, again this O. So L dash O. So that is the area we want, because this and this that can be written as in the letters. In the letters we can write like this: area of the region L dash O. L dash O, like that. Okay. Now this is equal to, I already said, to find this complete area, first we'll find the area of this. Then we'll multiply this area by 2, we will get total area. Okay. So area only, this means what? How can we write in letters like this? This one. This is O, L. Here what? S is there. So O, L, S, again come back. O. So I will write first 2 times of area of OLSO. Correct? So area of this part means, how can you write in letters? So it starts from O, it will go here, L, again come back, here S, again go back to O. So OLSO. So this area of OLSO is this part. So if you multiply area of this by 2, that is 2 into this, 2 times of that, we will get total area. We want this area, that's the question. Okay. Area bounded by its latus rectum. Okay. So we can write like this. Next. Now these two keep as it is. Now for this area of OLSO, we need to write the formula using integration. So first write integration. Okay. Okay, we have learnt, we heard that integrate with respect to x, we integrate with respect to y. Okay. We will integrate with respect to x because we have value. From here to here we have value a. So, okay, this one we will write. With respect to x I said, right? So with respect to x we will integrate. With respect to x means dx. Okay. Next, here we have to write the equation is there. No, here equation is there. Consider the left side here. This one. This variable we have to write. Okay, but the point is we should not write y square. We just need to write y. Okay, so y dx. Now limits, how to find limits? So with respect to x we are integrating. Dx means with respect to x. Now take x values on the x axis. Limits you have to take x values. That means, so we are finding area of this region, right? So the x values starts from 0 to this a. Coordinates are a, no, a comma 0 means, so this length is what? A. Okay. So the length of this area of region is from 0 to A. This is A, this length is A. So you have to take limit as 0 from 0 to A. Okay. Now the thing is, okay, we have to substitute the expression for this y. So we have y square is equal to 4ax. That I will take first. Y square is equal to 4ax. Okay. Now this is y square, not y. We want only y. So we have to remove this square. Okay. For that, take square root on both sides. Now this square and square root cancels out. Now what is left? So y is equal to this whole thing, square root of 4ax. Okay. I hope you understood till here. I will just erase this part except this diagram. Okay. Anything if you want erased content, just move the video backward. Okay. So till now you got right. Say this is y is equal to, sorry, area. I have taken here, right? Area A is equal to this. This I will write here again. So A is equal to this thing I am going to write. So 2 into 0 to A y dx. Y dx. Okay. Now next 2 I am going to write as it is. So this limits I am going to write as it is 0 to A. Now in place of y we have to write this square root of 4ax. Okay. In place of y I have written this, dx will be as it is. Okay. Now simplification. Okay. 2 you write as it is. Next this 0 to a you write as it is. Next remember, see 4ax means what? It's like 4 into a into x. Okay. So 4a is constant. A is the constant. So 4a is the constant. X is the variable. Just now I said it is like 4a into x. Because of multiplication, we can take the square root for constant separately and variable separately, like this. Square root of 4a into square root of x. So square root I took 4a separately like this, then for x separately like this. Okay, square root x. This dx you have to write as it is. Okay, so next so since 4a is the constant, okay, remember when we have integration of something and if you have constant and function or variable x, so you can take this common. No, take this not common. You can take this out of this integral, this side. So first write 2 asterisks. Now take this out of this integral, square root of 4a. Okay, this I took here. So write this integration limit asterisk. So 0 to a. Next to this root x dx, root x this dx. Okay. Okay. Next step, this 2 write asterisk root 4a. I will take here first for simplification. So 4a is like 4 into a multiplication. So because of that multiplication, we can take the square root for 4 separately like this, square root of 4 into, then take the square root for a separately like this. Now square root of 4 is 2. Root a write like asterisk. Okay. So in place of square root of 4a, I am going to write this. So 2 into root a. Here into is there. Okay. In place of this, I have written this. Next take this. So 0 to a. Now, okay. Square root of x can be, first write this x asterisk. We have to remove this square root. When you remove this square root will become half here, half. Okay. When we remove this square root will become power half of 1 by 2 for this x. So x to the power of 1 by 2. This 1 by 2 is nothing but the square root. When we remove square root, this change to 1 by 2. Okay. X to the power of 1 by 2. Then take dx. Next step, a is equal to, this is a is equal to, okay. So multiply this 2 into 2, 4. This square root a you write asterisk. Next, now this part we have to use the formula. First we have to integrate this x to the power of half using the formula. See, we have formula x to the power of n, integration of x to the power of n dx is equal to x to the power of n plus 1 whole divided by n plus 1. I will write this here. So integration of, don't consider this limit 0 to a. Don't consider now. First consider only this integration symbol. We will integrate this first, then we will apply the limits 0 and a. First we have to integrate this. Okay. So integration of x to the power of half of dx. Okay. So now see, this is in the form of this. According to this formula, x we have to keep asterisk. So n means in place of n we have half. So half plus 1 whole divided by, in place of n half plus 1. Okay. Till here you understood, right? I will just erase this upper part. Sorry. Here also 2 into 2, 4, 4 into root a. I written as it is. Here I am going to integrate, right? Yeah. Now before that, So I said before the limits, first you have to integrate this, right? When you integrate this x to the power half with respect to x, that means dx. So using this formula we got this, right? Now what I will do, in place of this integration of x to the power of half dx, I am going to write this. Okay, for that first you have to put bracket like this. So x to the power of half plus 1 whole divided by half plus 1. Okay, this I have written here. Now this limits you have to take 0 and a, like here 0 here a. Okay, now here x a is equal to this, right, as it is 4 into root a. Okay, next I will simplify this 1 by 2 plus 1, that we have to simplify first. Okay, see, 1 by 2 plus 1 will be 3 by 2. Okay, first write like this. So 3 by 2, in place of this I have written 3 by 2. Next this x half plus 1, 3 by 2, just now I showed this half plus 1, this half plus 1 is same. Half plus 1 is 3 by 2. Now x to the power of half plus 1 is 3 by 2, and this limit 0 and a will be as it is. Okay, next step. Now see, 3 by 2 is the constant. You can take here out. First write this 4 into root a whole divided by this 3 by 2, like this you write. Okay, now what is left? This x to the power of 3 by 2, 3 by 2, and this limits 0 and a. Next step, a is equal to, write this as it is 4 into root a, this 3 by 2. Now we have to apply the limits. First I will put flower bracket. No, first this square bracket. First we have to apply this limit, upper limit value, not this. First this. Applying upper limit means what? In place of x we are going to substitute this. Okay, first before that you have to put round, we have to put round bracket. You have to use round bracket for this x to the power of 3 by 2. So okay, first I'll use round bracket. So first we have to substitute this a in place of x. So in place of x I am going to write a, this 3 by 2. Now close the bracket, put next minus, this minus is fixed. Okay, next open the bracket. Now in place of x we have to substitute this value, lower limit 0. So in place of x I am going to put 0. This 3 by 2 will be as it is. Close the bracket. Next this is opened, this also we have to close like this. Okay, now next step, write this as it is 4 into root a whole divided by 3 by 2. Okay, bracket. Okay, so a to the power of 3 by 2 write as it is. Okay, see, remember 0 is there, 0 to anything, 0 to the power anything will be 0. We get 0 only. So minus 0. Okay, next step, so a is equal to this, write as it is 4 into root a whole divided by this 3 by 2. See, 0 means nothing. That means nothing, there is no any, there is not there anything. So we can discard this 0 and minus. 0 nothing, minus 0 nothing. So I will just write only this into a to the power of 3 by 2. So next step, write this part 4 into root a by 3 by 2 into, see, write this a first. 3 by 2 is there now, so we can write this as 1 by 2 into 3. Okay, see, 1 by 2 into 3 is 3 by 2, because 1 into 3 3, so 3 by 2. This we can write like this. Next step, next step, write this as it is 4 into root a whole divided by 3 by 2 into, see, this we can write first a to the power of, I can write, oh, use the bracket. This 3 can be written as here 3, a to the power of 1 by 2 whole to the power of 3. So we can write like that. That is a law of exponents. Okay. Now we got right till here. Next step, so a is equal to, I will write this part as it is. So 4 into root a divided by this 3 by 2. Next, see, a to the power of half can be written as, first write a into a, bracket should be there, this bracket, this a. So 1 by 2, it will become square root. A is there, this 1 by 2 will become square root like this. Okay, so open the bracket, 3 power 3, you have to write like that. Okay, next step, a is equal to this part 4 into root a by root 3 by 2 into, see, this root a whole cube is there, we can write root a whole square into root a. Okay, using law of exponents, like, see, a to the power of m into a to the power of n is equal to a to the power of m plus n. This I will take so root a whole square into root a is equal to, see, this is in the form of this. In place of a we have root a, in place of a root a, m plus n, this is m 2 plus, here nothing is there means 1 is there, 1. So what you will get, this root a 2 plus 1 is 3, root a whole cube. So root a whole cube can be written like this. How? Using this law. This is law of exponent. Next step, a is equal to, next I will see, here root a, here root a, here root a. Okay, so 4 and 3 by 2 are constant. I will separate this constant. 4 divided by 3 by 2. Okay, root a terms I will group one side. First take this root a into this root a whole square into this root a. So next step, a is equal to this. I will write as it is 4 by 3 by 2 into, see this root a, square and square root cancels out, we are left with a into a, this into root a. So next step, right, I will take a is equal to, okay, this I will take as it is 4 by 3 by 2 into, okay, see root a whole square into this a. Okay, next this I will write as it is 3 by 2 into, see this square and square root cancels out, we are left with a, okay, and into a. Okay, next step, this I will write 4 by 3 by 2 into a into a is a square. Okay, so next step, consider this. Here 4 means, just 4 means we can write 4 as 4 by 1, because when we divide 4 by 1 we will get 4 only. So 4 can be written as 4 by 1, this 3 by 2, equal to sign should be here along with this line, into this e square. So in the next step, keep 4 by 1 as it is. We have division, right? We will change this to into. When we change this to into, this 3 by 2 will become 2 by 3. This and this interchange, 3 by 2 will become 2 by 3. Why? We are changing this division as into multiplication. So we have kept this as it is. When this change to multiplication, this 3 by 2 will become 2 by 3. So into a square. Now that is equal to, see, this is numerator, denominator, multiply numerators. 4 into 2 is 8. So 1 into 3 is 3. This a square. Now this is the answer, area. Okay. 8 by 3 a square is the answer. So area is 8 by 3 a square, square units. Area will, the unit of area is square units. Okay. Thank you. Anything if you want to see related to this, my teaching, can mention the comment. I will follow that. Thank you. Click on subscribe.